Hello everyone, this is lecture 388. In this lecture we try to visualize the road estimate, how the road estimate, that is the earthwork, can be evaluated. So we have got different methods. So first of all we try to understand what is the cross sectional area of earthwork. It may be in banking or cutting, maybe above the ground level. If you raise the that is a flyover, etc. you create, then, and if you go for the tunnel and all, then you have to go for the cutting. So this can be in banking, this is banking, or embankment, and this is called the cutting. So usually what happens, this is a formation width which is created for the road purpose, and these are the side slopes which are maintained without any transverse slope, you can say. That is S is to 1, S is to 1. So this is a B, that is a formation width. These are the side slopes. Side slope S is to 1 means S horizontal and 1 vertical. So S means horizontal part एंड 1 वर्टिकल के रिस्पेक्ट में कितना आपका हॉरिजॉन्टल है, एस हॉरिजॉन्टल के रिस्पेक्ट में 1 वर्टिकल का रेफरेंस रखा गया है. तो यहाँ पर आप देखोगे कि अगर आप क्वांटिटी निकालना हो तो इसका एरिया, ये जो सेक्शनल एरिया है इसको फाइंड, यू हैव टू फाइंड आउट द सेक्शनल एरिया. सो व्हाट इज़ द सेक्शनल एरिया? 2 पार्ट इज़ देयर. वन इज़ योर रेक्टेंगल, अनदर इज़ 2 ट्रायंगल्स, रेक्टेंगल प्लस 2 ट्रायंगल्स. तो एरिया ऑफ अ रेक्टेंगल इज़ B into D simply, but this embankment on the other portions maybe D may be different. So this can be D1 here and D2 on the other sides. So the average D will be taken. So D is the average. In general you can say D is the D1 plus D2 by 2, that is average is taken. So S is the ratio quantity, that is BD into the area of this triangle, 1 by 2 D into SD. So 1 by 2 D into SD multiply by 2. So this is SD into D. So this is BD plus SD square simply. And if you multiply by the length, you will get the earthwork incavation for that length of the road or the that portion of the road you can calculate. So first method we called mid-sectional area method. Mid-sectional area method. Quantity area of mid-section, area of mid-section multiply by L. If D1, D2 are height of bank at 2 ends, L is a length, B is a formation width, S is to 1 means S to V, the side slopes. The area of mid-section will be area of rectangle per area of 2 sides of triangle. So we have done BDM plus SDM. DM is D1 plus D2 by 2. So quantity is the area multiplied by simply the length of the road. Now you can tabulate it in this form, that is the station or chainage from one point to another. You can station put 1, 2, 3 like that. So from station to station you can calculate the quantity of earthwork. That is depth or height, you can say mean depth. If you take the depth or height of one portion, D1 and D2, so mid depth D1 plus DT, BD, SD square, and the sectional area BD plus SD square, and you write down length on the side, so that in tabulation form you can either it is cutting or in embankment or cutting, that can be, this will be negative, this will be positive, something like that. So though you can calculate finally what is the earthwork is positive or negative, you can say you have to fill or you have to create on the upper side. So area of sloping sides, this is a simple way we have done. This is D, this is SD because this is SD, so this is SD. So this area will be something S square D square plus D square root over, this is called the sloping width, D root over S square plus 1. This is sloping width. If you have to pitching, you make pitching on the sides, lateral. So this area is required, which is nothing, area of both sides of slope, D root over S square plus into 2 with the 2 sides into L, the length of your cross section from one. So this can be also tabulated, that is station or chain is DRH, mean depth height, width of the side slope you can say d root over s square plus n, and length between station L, and you can always find out the total area of both sides and slopes. Total area of both sides and side slopes into length. This is quantity. So D being mean depth, you can always calculate the quantity, we required quantity earthwork, and the side for the pitching work you can have. So this is also important, that is this total quantity of you can say sloping surface areas total quantity, or D being the mean depth of. You can have a sub example for 200 meter length, height of banks 1 and 1.6 meter, B is the formation width, side slope S is 1, 2:1, no transverse slope, then calculate earthwork. So we can apply the method first. So quantity is a BDM plus SDM square into L. So you put B is equal to 10 meter, D1, D2, you can take the average 1.3 and put this value 10 in 1.5, 2 into 1.3 square into 200, we are getting 3276 cubic meter. So in this way you can calculate the what you call the earthwork in excavation, cutting or in embankment. If it is embankment, then it will be taken positive, if it is cutting, negative. So you can calculate this also in this way, 2L ds square mean 1. So this is your sides you can say sides quantity equals to your 2 into 200 into your D is 1.3 root over 2 square plus 1. This will be your quantity. You can calculate this and you can find out the turfing sides. So you can calculate how and multiply by this will give you the total quantity of surface required for pitching or for making some slopey, something like that. So thank you for being with me. I will continue for in another lecture for second method. Thank you very much.